Hey guys, welcome back to the channel. Today I am in Millstone, New Jersey, and I'll be putting in a new 22 kilowatt, 19.5 kilowatt natural gas connection standby generator. Standby, I want to show you some of the stuff that's going on here. My customer here is someone I used to play soccer with when I was like 10 years old. We were on the same soccer team. I hadn't seen him for a long time, but we both went to the same high school. But as you know, I'm in my mid 50s, and some people we just didn't keep in contact with. It was nice to come get a referral to see Ron again. So Ron, if you're watching this, thank you for the business. Let's get started. Let me show you what we're doing here. First, we had our generator delivered directly to my customer's house, only because I'm a small-time dealer and keeping it at my house is not preferred. So I get these delivered directly to the house and then dropped off here. You can see we are down a driveway. So when you order the generator from Generac, you have to have a certain set of conditions that you check off so that they don't bring a tractor trailer truck that can't get in here. So this is actually a smaller truck. You got to pay an extra fee for that. Usually delivery could be anywhere from $150 to $500. It depends. Then you have taxes. It comes directly from Wisconsin. These generators are made in the USA. Some of the parts are made overseas, but that's a nice product, obviously, Generac. This is where we're going to be putting the generator. I was here maybe a week or two ago getting started. This is 6x6 lumber that we cut the spec. You'll see in the earlier video, or a portion of the video I'm going to put up on the screen now. The pieces of rebar, we're going to drive these in, the rest of these today. When I came here originally, I did not have my SDS Max driver that I use to drive the ground rods, but we're going to drive these pieces of rebar into the earth through the lumber to keep the lumber in place. And then of course we backfilled with this pea gravel to absorb the vibration of the generator. And so the generator is going to live right here. It's important that we be at least 3 feet away from the side of the house, because this is going to be the intake side of the generator for the air-cooled generator. Now you're saying to yourself, well, that's less than 3 feet, but the generator is going to sit right in here, and it's exactly right at 3 feet. The other thing we're going to do, this will be the front of the generator over here. So all my connections are going to be right in the back side of the frame right there. And then of course you see my services right there also. We must keep at least 3 feet of clearance in front of the meter, which we will have, so that we can do the work. So today what we're going to do is we're definitely getting the transfer switch that's in today. This is a service disconnect for the house, which makes the installation a little bit easier, that I don't have to separate all of the grounds and neutrals inside the distribution panels. That makes it a lot less expensive as far as doing the work goes to my customer here. I've done this type of setup before, but normally it's either a pre-poured slab of concrete, or as you saw in my last standby generator, I did a composite mounting pad. That was the one in Garwood, the 22 kilowatt. This is actually a 26 kilowatt generator. But for here, the way the landscape was, I had suggested to Ron, the homeowner, that I could trim up some 6x6 pressure treated lumber, which you see me cutting here. And I get kind of excited to do this work. I do sometimes get bored doing electric work, so anytime I can do some carpentry or maybe some landscape construction, I get excited and I look forward to doing this work. And so that's what we decided to do here. And as you can see, the bags of pea gravel that are there. The pea gravel you'll see in a moment, we backfill in the center of this frame, and that's to counteract the vibration of the generator. So we make this cutout just a little bit longer than 48 inches. I think this was maybe 52 inches from side to side, and then back and forth you got to have a minimum of 24, and that was somewhere around 26 inches. So make sure you make the right cuts, and then we assembled this with some 10-inch lag screws, landscape lag screws, to get that going just right. This one really came out well, and I'm just waiting now to go back and make the final connection after the approval of the air test for the gas piping, and then we can start it up. That'll be in part 2 of this video. This will just be part 1 for the time being. Hey, by the way, now's a good time, if you like this kind of content, to like this video. And if you'd like to see more, you should subscribe, and don't forget to leave a comment. I really appreciate it, guys. Thank you.
I do have to mention here that this was ideal working conditions. At this point, I think this was like a cloudy day and it wasn't very hot in the middle of August. So at that point, you're very fortunate. There's nothing worse than working when it's super duper hot. I've been doing it for years. I hate when it's super, super hot. But at the same time, you always got to do what you got to do as far as making your yearly or your monthly, weekly income. Right? We all have our spreadsheets and we all got to make a certain amount of overhead to pay for everything that keeps Classic Electric going. So a lot of times in August, I'm not as busy as I am the rest of the year. It's kind of like a slow month, so to speak. There's plenty of work, but it gets so hot and people are on vacation. It's hard to schedule work. So I was grateful to be able to do this in August. I really enjoy doing this setup. Obviously, this was ideal location. I'm backed up into the driveway, and I'm about 15 feet from my truck, which is so ideal. Anytime you got to go through someone's backyard, maybe to the other side, maybe up a set of staircases, that could be always a pain in the neck. And of course, naturally, when I first started installing these generators, that's exactly the kind of situations I came across. There was one, I remember one time up in Chatham, New Jersey, that I think it was a snowstorm the day before we did the work, and we had the generator was there, and we were told we got to get the generator in place. We did, but there was ice, and we had to go upstairs. We had to come back downstairs. It was a lot of work. So fortunately, this one was a little simpler, maybe because I'm more experienced.
All right, so this is the cart for the generator. I've seen a couple of new ones that are out there. There's actually a motorized cart now. Which I think would be really, really nice, but it's close to $2,000. And so, being that this is only my, I think, second generator I've done this year, I don't do enough to justify a new $2,000 tool. Although I say that, and then you see me in the next video and I actually have the tool. So if it makes me money, or it makes money easier for me, well then it's worth it to buy those tools, don't you think? Now here my biggest challenge is going to be getting that generator onto the cart and then eventually onto that pad that you saw that I put down, or the frame, or the gravel. But what we're gonna do is probably roll the generator onto it, off of the cart, onto that platform. At least that's my plan for now. So I had a piece of, I think this is 3-inch PVC. I'm not sure why I had this, but this was on the side of my house, so I brought it today. So we have it. And of course, I like to bring my cart so I have something to put my tools down on. It was in my garage for a couple of weeks here. I haven't brought it out, but this is it right here. As you can see, I'm loaded up with Gatorade, whatever I gotta do here. Here's my strut. We'll drive this into the ground over here. We'll have to cut this ground rod driver attachment in here and to drive this rebar down. And we'll come back later with a different bit to drive the unistrut in the ground. But this works really, really good, as you're gonna see here.
So previously I drilled 1/2-inch holes through the 6-inch block right here. And the reason why I do that is to make room for the number 4 rebar so I can drive it through. Obviously I can't go all the way down. I come back with a sledgehammer and drive these into the earth. And what the rebar does is it keeps the 6x6 lumber in place with the earth.
Nice, nice. Now that rebar's in there, and this lumber isn't going anywhere. Good. Not bad. Good.
So on this property, we have an existing 200 amp service with a disconnect. And we're just going to replace this disconnect with the automatic transfer switch.
All right, so here is the meter. It's 200 amps coming in from underground. I believe that transformer is somewhere out there on the street. Not exactly sure, but it goes underneath. And I don't think it goes into the backyard there. I could be wrong. We have mostly underground services in this neighborhood. Anyhow, what we're going to be doing today is replacing these, which I know there's a service entrance conductors on the load side. So we disattach this one, disattach this one, disattach this one, and then we're going to put the transfer switch right next to it. In the back of this disconnect here are the load wires going into the distribution panel inside. It's down in the basement, and that's the scope of work for today. So any questions, please leave them in the comments. I'll be more than happy to answer those questions.
Anytime the wiring, the panel, the main disconnect is not directly behind where that meter is, you're going to have to put this disconnect in. And the reason why we did that before the required disconnect is because the fireman would have to find out where that main breaker was if it wasn't on the immediate opposite side of the meter.
Here, now here's a common violation. Not a huge deal here. It really isn't. This is the ground, or rather our electrodes. Well, the one electrode anyway. See the double tap on there? That would be no good by today's standards. Cannot do that. But apparently the inspector missed that, and he had another terminal right here to do that. And these grounding electrodes actually should have been attached over here, not over here, because the code specifically says, well, it's an interpretation that the grounding electrical conductors cannot use the enclosure as a raceway from your ground to, from your neutral to your ground rather. Even though it's bonded here, the main bonding jumper is in. This is where they separate from. This is where the equipment grounding conductor originates, inside this panel. But these electrodes should have been attached over here. And of course you have the terminals to do it, and they didn't do that. Instead they did a violation. Obviously everything worked out, but there's reasons why we have the codes the way they are.
The purpose of this section is to connect the grounding electrical conductor directly to the grounded conductor. And by doing that, it has to be on the same bus bar. If there's a wire, as like in the automatic transfer switch that bonds those two mechanical bus bars together, well then you can use either one of those bus bars. But you cannot depend upon the enclosure.
All right, now this gets a little tricky here, right, because it's an existing installation. So I need to make sure that my knockout on the transfer switch is perfect right on here. Okay, so I'm just going to take a measurement, and then of course I make my measurement perfect right here as well, which is not going to be the simplest thing, but I'm going to do the best. Looks like the center of them are both lined up evenly there, so whatever my measurement is to the bottom of the knockout that I'm going to make in the transfer switch is going to be the same height as the one in the back. So that gives me a little bit of point of reference. Now let me get a tape measure here so I can get a good measurement. And some of this is going to be a little guesstimate because it's never perfect here. Never a perfect situation. That plane sure feels low. It's a beautiful day. And if you're not following along at home, exactly what I'm talking about is I need to make a knockout at the top of this enclosure here so that the wiring from the meter can come inside my transfer switch. We call that the line side. It's going to go into the top side of the circuit breaker, the main disconnect here. And then the other hole I'm going to make is in the back. All right, there's my 2-inch mark. And we also want to go 3¼ inches here, which is here. All right. Let's just measure that height real quick. Two and a half inches up. Okay, so from the bottom enclosure to the center of that nipple is 2½ inches up, which we will mark right here. And right here. All right, so my hole's gonna be somewhere right around there. And we're gonna miss this knockout, thank God. And this one too, boom. Except we're not using the PVC, which I thought I was gonna do. We're gonna leave that steel nipple in place. The condition of it is fine as long as we put that bonding bushing back on. We're good to go. So I am ready to knock out the 2-inch. I'm just going to cut this out. That's locked in. I'm using my flex drill today. Not for any particular reason. I just have it. I like to use it when I can. All right, so right on my dot right there. So I'm making this hole. And once I get through this, enclosure is going to want to move around on me. See what I mean? Be careful of that kickback as it knocks you right out. And there you go. 2-inch hole, nice and clean. Be careful, that piece is hot after it's been through this bit here. Alrighty. Now we'll do the one on the back, and that should be a little bit easier with a lot less kickback going on there. I say that, but that might not be the case. Let's see. Alright, so same thing, just right on that dot. And boom. But let me show you the kit that I have. I think I lost the 1-inch piece, but this is the kit here. This is a Greenlee 648 quick change carbide hole cutter kit, 1/2 inch through 2 inch, which is so common for the work that I do. And as you can see, I'm missing one of the, I guess the dies you would call this, the 1-inch. Not sure what happened to it, but when you get these things together, as you can see, it comes with the arbor, and it just locks in place by that little notch right there. And it's even got a little ball bearing in there, so you can lock it into place. This is a really, really nice tool. It's kind of expensive. I think this kit was maybe 200 bucks. But if you're doing this professionally all the time, why would you not have something like this? We also could have used the step bit right here, a unibit, and then did the knockout, the mechanical ratcheting knockout kit that I have. That's also by Greenlee. And then we also could have used maybe a hole saw. Could have used a hydraulic punch kit. Milwaukee has a punch kit now, several $1,000s. I just don't do enough of this to justify the cost, although as I get older, I might be able to justify it a lot easier. This is the Greenlee kit. Works very, very well.
The automatic transfer switch is rated at 200 amps, and it's a service-rated disconnect switch, which means that the National Electric Code can recognize this piece of equipment as service-rated. So you can use it here as I am. This is going to be the main disconnect of the house. So when utility power is lost, it's going to send a message to the generator to start up, and approximately 10 seconds later, the generator will have started and transfer the load automatically. Now also keep in mind that this transfer switch is made out of aluminum, the enclosure, so you cannot use the magnetic properties of a box level to make sure that this is straight. So I got to use it on the top and of course on the bottom as well to make sure that it's level.
All right, so here's another little bit I'm going to use. This is by Milwaukee. It's almost the same as that Greenlee bit. So I can install this bonding bridge that's required. This will sit right underneath here. Definitely not required to do this right now, but it just seems fitting, and just to clean this up, because this conductor, the grounding electrical conductor from the ground rod up to my main here, was a little short. So instead of doing a splice in here, we'll just redo it. And since we're redoing it, now I got to add this. This is a better job. Not necessary, but this is going a little bit more than what's required, which is fine, obviously. And so I'm just gonna you see that just makes a little hole, 1/2 inch hole right here, so I can put my my bonding bridge in there. And what ends up happening with this is there's a little set screw right here that actually makes that physical connection to the bonding bridge right in the middle there. See the set screw? Right in the middle. So when I run that wiring up in there, I'll strip it right at that point so I can make a connection to it. All right, it will be bonded obviously through the enclosure, but the manufacturer has this there, so we're supposed to use it. All right, so I'm gonna strip it right around here. Just a small section. There, now you see how it just comes straight through there? believe it or not, this does not have to be green. It should be. If they made that code, I wouldn't be upset. But this is not required to be green. All right, so now we'll have to extend our grounded neutral to the load center and also our equipment grounding conductor to the load center. And we'll also have to extend our feeders. It's a shame because I'm like 2 inches short. Oh. Okay.
The conductors that I'm extending here are the ones that go to the distribution panel inside the house. You don't see that in this video because it's already downstream from this main disconnect. So there's no work that needs to be done there as far as removing the neutrals from the grounds and isolating them. That's already been done when this house was made. There was no slack on this wire, and because the old disconnect had the lugs at the bottom, this one, just the lugs in this transfer switch are not in the same place, so I had to extend these conductors. There was no slack on the inside, and we can't put them into a junction box, although I guess we could. I chose not to. I chose to extend these conductors to the load side of my transfer switch.
Now this one has to be identified because this is the equipment grounding conductor. These black ones that don't need to be green are the grounding electroconductors. I know that's kind of silly to require for one but not for the other, but they serve two different purposes, as we've been over before on this channel. The equipment grounding conductor removes faults on the system, and the grounding electroconductor prevents lightning damage, or prevents transient voltages, as Michael always says.
So all that this transfer switch does is it senses when utility power has been lost, and then it also sends a message to the generator to start up, and then when the generator is ready and the voltage is being supplied accurately, it sends another message back to the transfer switch to switch from the utility side to the generator side. That's that little yellow button in the middle there. There's two different coils, one up on the top, one up on the bottom, to make this connection and to transfer between the generator load, the generator source, and the utility source. I'm just using regular butt splices that I use to cut in all my services to extend the conductors here. It is kind of a shame that the conductors didn't reach to the terminals, but this is what it is. And this was the only place I was going to be able to get this to come into the transfer switch here. I didn't have too many options here of what I could do without ripping apart the siding and the sheeting behind it and making a bigger mess than is necessary. So this is what I had to do.
So this is definitely something I haven't been asked to do before, but since the 2020 code in New Jersey has been the electrical code in New Jersey, you have to put the surge protection in for services. And if you read that section closely, I believe it's 230 Tech 67. It could be 230 Tech 85, I forget which one. One of them's the disconnects, one of them's for the surge protection requirement. So we're updating the service equipment here because this is now the main disconnect, this transfer switch. All right, so the inspector here is asking me to put in a surge protective device, which I'm doing. I had one, I'm not sure where I got this one from. Generac. It's been on my truck for a little while, I'm not sure. What we're going to do is we took off these two nuts right here, and they go right here, which is the load side of the main disconnect here on these lugs. And so we're going to put some crimps on the ends here, and then that's where we're going to attach it inside those posts. Okay, so let me show you the connection, since I didn't start the camera up to show you the connection. So obviously we have our type 1 surge protection device, which is on the line side of the service equipment, the panel I should say. And went to these lugs right here. So we take this away, this is where our line side conductors from the meter will go, and they'll pass through. Right now it's off, but once you turn this on, this will become energized, and these posts are 240 volts between each other. Okay, 120 and 120, and that's where we attached our surge protective device inside the automatic transfer switch by Generac. All right, so to keep that cover over the main lugs for the line side of the automatic transfer switch, Generac gives us these little screws that come in with the owner's manual automatic transfer switch package, and those little black screws are right there. All right, that's what you use to attach that cover over the main lugs, which is required by the NEC. The right tool for the job. All right. It's a small Phillips head, not very big. Don't force it in when you're number 2, which is what I normally have, number 2 Phillips. Alrighty. I'm not sure what size this actually is. Probably Phillips head 3, I believe, or 1 or the other. Always want to make sure you got the right size here. So this is the die that's going to make the hole. We want to make sure that that is going to be just the same size as the male end of this connector here, the threads. This is going to go inside this lockdown, will come off and it'll go inside. So we're going to make the hole with this die right here.
This is 1.25" non-metallic seal tight, liquid, flexible, non-metallic B conduit. This is for situations where you need some flexibility. So what I'm going to do here is attach it into my transfer switch and then put some straps with some lag bolts. And I'm going to leave the tail end of this until I get the generator in place. And then in part 2 of this video, you'll see how I wire the generator. But that's what the liquid flexible non-metallic seal tight is for. Flexibility, and for, of course, for the vibration for when the generator starts up and is running. We want to make sure that that connection is not loosely moving around, or rather it can loosely move around instead of having a piece of rigid PVC attached to it directly. The same thing goes for the gas pipe connection, which I unfortunately do not have any video of because that's another contract that does that work. But of course, we'll review that work and you'll see that there's a flexible piece of gas piping that actually comes with the generator to take care of this vibration that I'm talking about when the generator is running. Any questions, please leave them down in the comments. I'm more than happy to answer your questions about that. If you didn't already know it, this generator is approximately 500 pounds, so it's super heavy. And I have always struggled with moving the generator to where it's got to go on someone's property. Sometimes it's a piece of cake. Other times it might take you 3-4 hours to do this yourself. I've cut 3-inch conduit, 2-inch PVC to roll it. I've done everything. I've had 4 guys there. I've had the plumber there to help me move it. We move it. We can move it like a casket. We put the steel through the generator and walk it like a casket. I've done a lot of things to get this generator to where it's got to go, but this one was by far the simplest one I ever did. Hopefully because of my experience. But moving this generator is a pain in the neck. And as you can see here, I'm going to remove the cart from the generator once I get it up onto this pad that I made, and then I'm just going to slide it around. It was pretty simple after that. So